that we're having trouble with, number 2, this one here, just confirm again. I'm going to lower the hands. Just confirm again. Who got this one right? Number B, number 5. Who got number 5 right? Please raise your hands. Nobody got number 5 right. It's B, by the way. So one person got number 5 right. Okay, so I did 2. Okay. So this is in chapter number... Where is it? Chapter number 9. Okay. The problem is they did ask this in the quiz. Okay. Can't remember if chapter 9 is, but this is something that you guys need to know. So, so the question is now, and by the way, I think hard links is in the same chapter. So hard links, and this is in the same chapter. Okay, you don't have to raise your hands. You can just give me, oh, you know what, raise your hands. Who wants me to quickly go through the stuff in chapter 9, just so that we can refresh that. Okay, 5, 6, 7, 8, 9, we're at 10, we're 20 people in the call, so we're at the majority, so let's go. Okay. Going to run this more like a class than a study session. So if you guys are okay with that, let me just do that. So in the Linux world or in the Unix world, I'm going to just get my other screen up here for you guys with my meeting. Come on, meeting. I want that to go full screen. I press this button and that button. There we go. You guys are boring because you're not on the thingy, so. Linux. How's that for explanation? So this is the explanation, yeah. Start with something new. Okay. In Linux, if you think in terms of a file, okay, you all know what a file is. I'm assuming, considering you've been working with it for 6 months, you all know. Yes, Sejo, do you have a question? Or can I just lower your hand? Okay, cool. So we all know what a file is. Okay, so a file is just basically a thing where we store information in. Okay. Now, every application in Linux, okay, remember we said right in the beginning, Unix, okay, guys, I need to write it that everybody can read. So Unix, everything is a file. Now, when I start any application, any app, Linux creates three standard files that they always attach to that. The one file is called standard in, standard out, and standard error. Error, spelled properly with 2 R's. Okay. Standard in is always file descriptor. File descriptor. File descriptor 0. Standard out is file descriptor 1. Standard error is always file descriptor 2. Okay. So that's the one.
Excuse me.
Yes.
Where are you writing this?
Are you not seeing that? I did share it out. Let me just share again. You're not seeing that. Okay, let me just stop this. Sharing there. Can you see that? Can you see the sharing there?
Yes, I can see that now. Thank you.
Okay. So we have the 3 standard in, standard out, standard error. Now what Linux does is it has things like a greater than sign and a smaller than sign. Greater than sign is standard out, standard in. So if I run a command, say for example, ls, okay, then I can, okay, let me just go back to the stuff here. Okay. So that is the basic principle. Just give me, let me just see which one is cool. Okay, give me a thumbs down if you don't understand so I can explain this slower. Okay, nobody that's struggling with this. Okay, so the concepts are very easy. So we have, now what we can do is, we can connect one application's standard out to another application standard in. We use a pipe symbol. Okay, there's two dashes on top of each other. Okay, in short, we'll just write it like that. And on your keyboard, it's above the backslash. If you look at your keyboard, above the backslash is a pipe symbol. Okay. So what I can do is, I can, for example, do the following. Say, for example, I want a ls that is sorted. I can do ls pipe sort. And what that will do is it will take ls's standard out and connect it to sorts standard in. Yeah. So that is the principle. That is a pipe symbol. We had a lot of pipe symbols in the quiz, so that's it. So you can think of a lot of things that we can do with it, and I think we'll play around with it a bit. You guys, if you have, if you're on your laptop, you can open up your Linux. We'll play with it just now, and we'll look at the pipe symbol. But what you can also do is, I can say, I want the standard out for ls to be saved to a file. So we call the file name. That I can do. So that tells me take ls and output it to a file name. I can also do the following. I can say, okay, sort, but instead of taking a pipe symbol, take from standard in, and I'm going to define standard in as file name 2. Okay, so that is what these symbols mean. Now, the reason
Okay,
that
I
you
have
guys,
a question.
yes,
Okay, should I let you finish? Um, when you said ls, right, to
mhm,
stand it out to file name,
yeah,
are you basically saying that all the lists will be converted in a file name
no,
in
it'll be
the file
saved.
called
It'll be
file name?
saved to the file. I think let's do a demo of that quickly. Let's see if I
Okay,
can get
thanks.
my thingy on here. That's what happens when you have too many things open and you're old and you forget where things are. Okay, let's have a look. There we go. So we'll just start that one up quickly. And we will quickly share it out on the side. Window, one there. And I actually want to open up the screen so you can see. Okay, there you go. That one there. So it's just booting up and I'll just show you quickly. Let's have a look at Alice. I don't think Alice. See, unfortunately, Alice already sorts. Let me just think of another command. Let's do this. Shuffle. You remember this command? 1 to 100. Shuffle. Okay. So you remember what shuffle does? It takes all the numbers from 1 to 100 and just puts it in different order. Okay, that's all it does. Now, the first command we did was the pipe symbol. So if I can take that and say, well, it's shuffled. So it gives me an output that looks like this. I say, take the standard output and make it the standard input for sort. And now it's sorted. Now you'll notice something here. Notice that it's sorted in string order, alphabetically. It's not sorted
Yes.
numerically, it's sorted alphabetically. So what we can
Mm-hmm.
do is we can now go numerically, and now it's sorted numerically. So I've taken the output for shove, okay, and I've put it to the input
Mm-hmm.
sort. Okay. But let's do the following. Let's just say I do shove. I want to, we don't need 100, we can do 25 because it's easier. No, let's just work with 20. Oh, it fits on the screen. So I've shoved I to 20, and I say, okay, you know what? Put that into numbers. So I'm telling take shove, standard output, put it into the file called numbers. Enter.
Okay.
If I now open numbers, can you see inside the file? It's now put the output.
Mm-hmm.
It's now put the output for that into that. What I can now do is I can do the following: say sort and say connect sorts input to that file.
Oh, okay.
Okay, so you got the input, standard input, you got the standard output. Okay, that's one of the reasons.
Got it.
Yeah, if you do bash, in bash you'll see in bash you can't do this. In bash, when I say if is 10 smaller than 9, then echo hi. Okay, that won't work. Okay,
Mm-hmm.
because the smaller than really means output. So you have to use less
Oh,
than.
output. Yeah.
That's why you use less than or greater than, because the greater than and the less than sign is used by this. That's why it's
Right.
okay. So the
Okay.
question now is, what happens if I want to use standard out? Not standard out, standard error. Remember I said standard, the things have different numbers. So what I can do is I can do the following and say, fine, I want to run a command. Sort is a command that never gives an error. Let me see if I can find something that gives an error. Which command gives errors? You got some commands that did some errors. Let's do this. App install hello world. Okay. You see it gives me an error.
Mm-hmm.
Okay, now it's okay, fine. What I want is I'm writing a script. I don't want people to see the error. So I'm going to go errors. Okay, now let me just fix that first. You see it didn't give an error anymore.
Mm-hmm.
Okay, because we said pipe file descriptor to errors.
Mm-hmm.
So you can do stuff like, for example, this. You can do this. You can say, you can even use one there, output and errors. So if you look at output, you'll see there's nothing in there. But if you look at errors, you see the errors there. Because I've
Mm-hmm.
typed symbol 1 to output, symbol 2 to errors. So that's the symbols. Now the only difference between this and this is exactly what we did in Perl A. This is a create. This is an append.
Mm-hmm.
So let's do this. So we'd say we've got this file called number. Okay, let's get numbers, whatever. Okay. Piper to sort. Actually, yeah. So we just do this. So we take that number and we say numbers 2. Look at the numbers 2, and you should see
Mm-hmm.
all the numbers on there. Now say take cat numbers, sort them numerically, and output double, which means appends to number 2.
Okay.
And now you'll see that this is the first part, which we did the first time, and this is the part that we did at
Mm-hmm.
the end. So if you go back to that command there, number that one, can you see that now? Can you see the answer now?
Yeah. I see.
Okay. So that's chapter just in the class. So,
But what's up with that, guys? Why are the lecturers not teaching us in class?
must I give you my honest opinion? You can't tell the lecturers this. Is there any lecturers here?
No, they're not lecturers. Yeah, it's just us.
They
But
they
honestly,
they just don't have experience. They just don't know the system yet.
why are they there? Do you know how much money we pay to go at this freaking institution?
I
Like, this is
know.
not funny. Yo, Bobas.
I paid the same. I understand exactly where you're coming from. So exactly. I'm hoping the second and third year is better, but yeah, there's not a lot of Linux experts or Linux experts out there, and
Oh,
these guys just do not have the experience yet. So also they started with this is the second time they've given the subject. Last year it was actually worse than this year. So this year's
what?
actually gone better, yes. So
I'm
yes.
so upset. Oh my God. Okay. All right. Let's move on.
Okay. So I'm just gonna see, is there a way for me to move this over here so you guys can see? Um there should be a button here. No. Okay. Share window. Okay, so we've done the pipe symbol, we've done the standard in, standard out, standard error. We've done the greater than symbol, the smaller than symbol, the double greater than symbols. Okay, so and we've done the 2, 1, and 3. Okay. There's one command that you sort of have to know. So let me just find it here because it's not something that I use a lot. Um, what they love to do is they love to ask this question. They go, you want to output both your error and um, your file to the same directory. So they ask this question. They say output both error and standard out. Let me just put this so you can see it. So they say output both error and standard out to the same file. Okay, they love asking this one because it doesn't make a lot of sense. So you can do so, for example. So we know that if you do this, okay, and we do that all.txt, then it's going to output to text to all.txt. Okay. But if you want to add standard error to that same thing, what you can do is you would do this. Okay, but you can also do is you can do this. Oh, by the way, you need to do the background thing as well. We'll work with it. Okay, and that'll give you that both the output and the error is going to go to the same file. That just says references that thing there. Okay, it's a special command. It's a weird one. Just know it. It's not. There's no real logic about it. That's just how it works. Okay. Now we talked about in one of the lessons we talked about the dev directory. Okay, the dev directory is where all your devices are. Now, Linux has got a couple of special devices. One of them is null. You'll see it's here. Okay, and one of them is 0. So what does cat do? Cat shows you what's in a file. So if I say cat null, see there's nothing in it, just empty. If I say cat 0, it's got zeros in it. It's just got zeros in it. Okay. So what you can do weird stuff with it. So you can say, for example, cat dev 0 Oh, that doesn't work. Do you remember the DF file, by the way? Remember this? Thumbs up if you do. Okay, there we go. Output file, test.txt. Okay, now you'll see the test.asf, the one that I just created, is 92 megs big. And if I open it up, yes, it's just got zeros. Those are basically just zeros. So, def0 contains literally just zeros. It just gives you zeros forever and ever and ever and ever and ever. Okay, and def null has nothing in it. So what you can do, for example, if I run a command, so remember we try to run apt install new world. Okay, and then you say, okay, fine, we want the output to be to the error output to be to error. Okay, now I've got a file called error. But a lot of times I don't want that. So what I can do is I can do the following. I can say apt install new world, and I say take the error and just push it out to def null. So def null is literally like the dustbin. So you do that, and then what happens is it just throws the data away. Okay. And
Okay, wait. So wait, hold on. So it throws the error away, as in if someone were to type in that error in that Linux system, then they'll never get to read the real error.
Well, the error is now. So what's happened is all I've done is I've taken standard error, the output for the error, and I've piped it or exported to def null. And def null just basically means disappear.
Okay. So the user experiences, what do they see?
Oh, they won't see anything. So if I run it like that, nothing. Just won't display anything. So if I do this, it displays the error. If I do this, it doesn't display the error.
Oh, okay.
Sometimes,
Okay, so
yeah.
then why did we do that?
Sometimes you want to throw it away. Sometimes you're not interested. No, I'll show you. Okay, let me show you.
Okay.
So what happens is I have this command there, okay, that's got an error. So what I want to do is I want to run an if command. So I've done an if command. Echo successful install. Else echo no bugger up. Okay, okay. Can you see? It said no bugger up, but it's got all this noise up here that I'm not really interested in.
Mm.
So what I can do is I can say, okay, fine. Take all the errors and just throw it away.
Mm-hmm.
Okay, and I can actually do this and we can make it look better, and you can do this. Okay, so that's the type of thing that you would use it for. Is sometimes it's worth it. So what happens is in applications is in Linux, if an application is successful, it returns a 0. If it's unsuccessful, it returns a 1. So what happens is if you do an if statement, let me just do the if statement so you can see where this is coming from. Okay. So basically, okay, so let's just do this. So if it's a successful command, like ls, okay, it'll run that. If it's unsuccessful, it'll run the second part. Okay, so even an ls, so we can do, for example, an ls, okay. Now you see what happens is it prints all this, which I'm not really interested in, and then it puts it up. And I say, okay, you know what? I'm not really interested in what you have to say there. So what I want you to do is just throw that information away, and I'm not really interested in the error messages either. That's what you would typically use it for. You're just selling it to throw the stuff away. Are you guys with? Okay, cool. Ta-da-ta-ta-da-ta-ta. Okay, let's have a look at what else you guys were struggling with. Um, where are we now? We're like a freaking hour into this yet, so we haven't really done anything. But it's fine. Just go back to that share thing here. Ta-da, ta-da. Okay. Next one you guys are struggling with is hard links and soft links. Okay. Just to,
Okay, so are we going to ignore the relational expressions?
the relation.
I'm just asking.
Now it's part of Bash, though. Do you want me to do that quickly?
Oh no, it's all right. We can continue with the. Is it hard disks?
Hard links and soft links.
Hard links. All right, let's look at that.
So I'm a bit worried about this one because you guys didn't even guess randomly.
Let's take a look.
We should have got like a 10 maybe if you just guessed, but okay. But you guys were maybe just honest. You said, well, I don't know. Okay, cool. So we got a 2 there for hard links and soft links. Now this information for that one is in chapter number quite late actually. No, it's not late. I thought it was later. There we go. It's chapter 6. Okay, it's in chapter 6. So let us try and explain this to the masses. You guys remember anything from chapter 6? Guys, remember that we did chapter 6 at all? Hey guys, you can really interact with me. It's really like nothing here, talking to myself. If I wanted to talk to myself, I would just talk to myself. I don't have to have a meeting for that. Okay, there we go. And if I press a button key here, I should be able to do there. Okay. You see, I actually like the fact that it figures that thing out. Okay, cool. So let's talk about hard versus soft links. Now you remember in ITCNA, we talked about IP addresses and everything, and basically every computer has a unique number and stuff like that. Now,
Yeah.
computers are much more comfortable with numbers than with names. So Windows, by the way, does the same thing. It's just that, and we're going. So Linux, for each application or each file that you create, it gives it a unique number. That number is called an inode number. It's called an inode. Okay, so inode is literally just the file's number. And we'll play around with it just now, and I'll show you how that works. Now, the commands that you need to know, chapter 6, are things like stat. Flipping hell. I always forget there's people watching, so I have to write it. Just semi-legible is stat. And the other command that you can use is
Okay, but
ls.
when you use the greater than sign, now it's confusing us because we had already defined
Okay.
what it is.
Let's do this. This is just the prompt. You can ignore that part. Just so you know that's a command. Okay, you can ignore that part. So the command is stat and this command lsi, and what that will do is it will show you the inode number. Okay. Now in Linux, what you can do is, say for example, is I've got two files. File one, file one, and file two. Now what I want to do is, I want the content of these two files to be exactly the same. So what I would normally do is I'll say, okay, I've got file one. If I want the content for file two to be the same, I'll just copy file one to file two. Okay, and then file one and file two's content is the same. Then some person over there goes, no, file one, and he goes and edit that file. Now these two files are not the same anymore. Okay, that is a problem. You don't want that. So in Linux, you've got something called a link. In a link, I can say that this file and that file is the same file. The contents should be the same. Okay, and we've got two types of links. We've got a hard link and we've got a soft link. And I'm going to do a hard link first because soft link requires you to think about the thing. So a hard link is just basically if I say link file one to file two, these two files are now exactly the same file. They just have different names, but internally they're exactly the same. They've got the same inode number. Everything is the same. Okay, so let's just do that quickly and I'll show you. So let's go to Linux. Guys, thumbs down if you don't understand, if I need to explain it slightly with a bit more detail. Okay, we got a thumbs up there, so we're fine. Okay, so let's go to my Linux thing. Let's do that little experiment that I just created. So I've got a file. In this case, we've got the file called number two. So we say, let's just move that number two file. We just rename it to file one. You say, okay, fine. So we've got file one. That's what's in file one. Let's say copy file one to file two. And now they're the same. File one and file one and file two are the same. But now I'll go into file one and I say, no, I don't like that. I'm going to delete all this crap here. Okay, and you guys all logically know this because it's really not brain scientists and you figured this one out 1,000 years ago, but regardless, let's go through the whole motions. Now if I look at file one, it looks like that, but file two looks slightly different. Okay, so that is what happens there. So we just did a copy. What we can do is we can do the same. So link file one to file two. But now cat file two, you see is exactly the same as file one. What's cool about it is if I now go and say, oh, you know what? I'm going to edit file one. I'm going to go, Marwa is cool. So now I can look at file one. So I've changed file one. Look at this. File one and file two has got exactly the same content. The files are the same thing. Now here's where it becomes interesting, and this is where it really is. If I do stat file one, can you see there's the file name? The size is 65 bytes, blocks and yada yada, all that you can ignore. It's just number keys. And then you see there's an inode number here. Okay. Now let's do file two. What do you notice about file one and file two? The information is exactly the same. It's the same file. just has a different name. It's literally the same file. If you look at this little number here, just tells you how many files are linked to it. So if I remove, say, file 2, see file 2 is now gone, file 1 is still there. See, now I just got no one link, and if I link a new file, file 1 to file 2, file 1, and file 2. See, they're the same file. Even if I edit the one file, even if I do this, okay, can you see the access and modify dates have changed? And if I look at file 2, they're exactly the same. So in Linux, and this is also a really important concept, the file and the directory entry are sort of separated. So what you basically have is your directory entry, which is all the names of the files, literally are just names with pointers to the actual file. So I can create two names that's got different names, and they're both pointing to the same file. So for all effective purposes, it's the same file, it's just a different name for the same thing. Okay. You guys, sorry, this is very racist, but I'm going to say it anyway. It's like you guys that's got multiple names. Doesn't matter which name I call you, okay, it's still the same person. Behind the names, the same person. Okay, we have that.
Oh my God, you're so racist. What?
I just, you know what happens is why I'm saying that is because it's a lot of, especially black people, what they do is they've got this name that they give to everybody so everybody can understand it, and they've got a name that their mom calls them. They're not the same thing. Generally, not always, generally. But yeah, so that's what happens. So you got different names, points to the same person. Okay. Yeah, our white people, what we do is we force you to say our name. Black people just, you know, it's too much effort. Too much effort. Okay. So that's the one thing that we have. We have that link. Okay, we have that's called a hard link. Now, what we can do is we can do a soft link as well. So a hard link points to the actual file. The soft link just says this is a reference to the file. So it just points to the other file's name instead of to the actual file. Okay, so let's do the same thing now. I'm going to do file 2. So let link, that just stands for symbolic link. So let's make it symbolic link between file 1 and file 2. If we do stat file 1, we'll notice the inode number there and everything. Now do stats file 2. Can you see it looks completely different? Okay, it's got a different inode number, it's got different everything here. Okay, yet if I open up file 1 and if I open up file 2, they're still the same file. Okay, and you'll see here, let me just do a long listing. You see here where it says file 2 are referencing file 1. Where, when we did the hard link, let's just do the hard link quickly. When we link file 1 to file 3, LSL, you see that you don't even see that it's a link. It looks like it's the same file. This one is very obvious. Okay. And there's a couple of reasons why you want to do that. One of the things is each file is unique. It's got a unique number, but it's a unique number per file system. So if I refer to a file on another disk or another file system, then the inode number is not going to be unique, and then it's a problem. So then you can use the symbolic link. The other thing that's important for symbolic links is you cannot do a hard link to a directory. So if I try to link videos as a directory, so videos as a directory, and I want to do, I would say YouTube cool stuff. Okay. It's just going to give me an error. But if I use a symbolic link, there we go. Now I've got this file and it refers to videos, and I can literally go CD, YouTube cool stuff, and it's going to go to my videos directory. Okay, question. Yes, you had a question?
No, you added context, so now it is very clear.
Okay, so the places, it's not really in the book. You don't really need to know that. The places in the book or in Linux, not the places, it's not in the book. This is something that you sort of just have to know. One of the ways that they manage that is, if you look at your etc directory, let's just do this. What's a nice one? Oh, RC. It sort of changed it. Okay. Okay. So here is a lot of startup scripts. Now, what's to happen is, for example, when I'm in graphical mode, I want to run that application. So what I can do is I can say RC3, and you see these are just some symbolic links. So I've got my original configuration file on my let's say, for example, we do it in a cron because that's a good example. So in this case, what happens is wherever I want to run it, at which run level I want to run it, I just have a symbolic link. But let's do it in cron, for example. So because you know about cron. So in Linux, we've got a subdirectory called cron daily. Okay, it runs all these commands. Now I'm creating a new script. I'm creating a new script, and I'm going to call it backup script. Got it called backup script, and it basically does a backup. Now what I want to do is I want this script to be in the backup. So I can copy it, but that's now a problem because every time I want to change the script, I have to copy it again. But what I can do is I can go to my cron directory. Hey, come on, open. Just see if it's this one. Yeah. Forgot my password. There we go. Okay, cron daily. And I can say link, whatever's in my home directory, backup.shell. I'm going to just call it backup on this side. And now I've got the backup file here. It's got the same contents as home Jacobus backup. Okay, but it's nice and sorted out. One day when I want to change the backup script, I literally just remove it here, and then it doesn't work anymore. And the moment I want to enable it, I just copy it here again. And Linux uses a lot, where they just have a symbolic link to the original file to enable or disable stuff. If you're going to work with, I don't think I've got patch here. Okay, so your web service, for example, does that. So the web server, they do that a lot. So you have the web server, you've got your configuration for your website, and then you create your original configuration for the website, and you literally just link your original configuration into the subdirectory for the configs for the website, and your website gets enabled. And when you're done with the website, you don't want it anymore, you just delete the config file, but your original website and configs and everything are still intact. Okay, so those are hard and soft links. Soft links, remember that a soft link, so for example, and this is quite important, so backup file points to the original file. But if I go to my original file, and I say, for example, rename it. Okay, now I've renamed the original file. If I go back here, Crondeli, you'll see that it's red now because it is not linked anymore. Okay, it's not linked anymore. That's for a symbolic link. But here's the thing. with a hard link. With a hard link, okay, this is now a hard link. Okay, if I go to the original file and I change it, okay, and if you see now I've changed the name. If I go to my original, you'll see it'll still work because it's pointing to the actual file, while a symbolic link is just pointing to the name of the file, not to the actual file itself. Okay, it's important to know they have asked it in the past. Okay, let's see. Where are we? So we have now managed, how do they say in Harry Potter? Mischief managed. Mischief managed. There you go. Okay, the df command, you just need to know that. Do I need to go through this one?
Well, no. Okay, so in all, how would you define hard links and soft links using simple
I can't,
language?
using simple language. How would you define it? How do you understand it?
Oh my God, I don't understand a thing.
I,
My God, like I see the technicalities of things, but it's so hard to articulate what the hell I just saw. I know people are
Like,
laughing.
can
But
I ask,
like,
oh,
yes, please go.
would you say that a soft link is just a file that points to another file,
it doesn't point to the file, it
Okay.
points to the file's name.
to the files? Okay.
Okay.
Yeah, so
And then a hard link.
a hard link points to the actual file.
Hmm. File
So,
name.
Oh, so that's why they have different inroads. Okay, okay, I
Yeah.
see.
Okay. Gosh. Wow. And they don't
but
teach this in class. Ugh.
again, it's quite fundamental concepts, these, because they tend to you eventually going to run into them. And we have to do another concept very quickly before we end. Otherwise, I think it's quite important. Okay.
Oh, and then just to make sure as well, with the soft link, if we don't point it to anywhere, then it becomes useless.
Yes.
Okay.
There's just nothing in there. So I think I'm going to try and explain it in a different way. So if you think about it like this, so let me just clear this up. Let's see if there's a little clear button here. Clear all. Oh, there we go. All my learning work done. Okay. So I've got a person here. Okay. Her mom calls her Sarah. Okay. Everybody else calls her. Okay. Let me just do this. We'll be nice today. So everybody else calls her. I don't know. What is another word? Okay. They point to the same person. Okay. They point to the same person. In the case of a soft link, okay, what happens is we have Sarah's name written on a document somewhere. And then when she puts her name on something, Peter, what we do is we refer to the name to figure out who the actual person is. Okay, so it's indirect. It doesn't go directly to the person. It refers to that name, and that name then points us to the right person. That's the difference. So a direct link or a hard link points directly to the person. A soft link refers to the name, and that name refers to the thing. So all you can just replace the person by a file. It's going to be a file here. It's supposed to look like that. Okay. So a hard link points directly to the file. A file, remember, has got an inode, which is the file number. So the file 1 and file 2 has got the inode number, and it uses that inode number to get to the inode. A soft link got file 1, it's got an inode number, points to the file. Okay, now I've got file 2 here. File 2 has got its own inode number. This inode number is not the same. It points to that file to be able to get to that. That's the difference between the soft. So a soft link is an indirect link.
Okay. All
Yeah.
right. Okay, so why?
Why?
It's so dodgy. I mean, the inodes numbers, why would they be different for us?
Okay.
Link.
So hard links, soft links are handy. The problem with that is that if I've got a hard drive here, okay, it is easy to make all my files in there as inodes unique. It's very easy. I literally just ask, get a new number, and I'm always sure that the inode numbers are unique. What happens if we've got a second hard drive? Okay, now I've got a problem. Because say, for example, I start first inode 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Hard link, I can't link these two because the inode numbers are conflicting. But with the soft link, I can, because in the soft link, I can say, just look at that hard drive and use that file name to get to that file.
Wait, didn't you say that about the soft link?
This is a soft link, yeah.
Wait, the soft link, isn't it the one where you can call it by a different name, but you're calling the same file?
Both of them do that. The difference is the hard link, the inode numbers are the same.
Okay, so it's the hard link where the inodes are the same.
Yes. And a soft link, you're just linking to a file. So the soft link is the indirect soft link. Indirect soft link. So soft link is indirect. So soft link, we can do things like directories, link directories. We can link things like remote files. You can use soft links for. Hard links can't do that. Hard links has to be on the same device. Go sleep on it, you'll get it. Okay, awk.
Oh, yes, I get it. Yes, sorry. I couldn't find my mic. Yes, got it.
Okay, awk. So the next one that you guys are struggling with was awk. Awk. And I do not blame you because I also struggle with awk. Okay, there we go. There's awk. So the next one you struggle with, the question was, awk command can be used to both filter and format text. Okay, and we only got 4 people that said yes, it can, and got that one right. So can anybody, and I'm happy with, doesn't matter who answers it, tell me what awk does. In actual fact, I want to check something while you guys are answering. Waiting for an answer. No, 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 no.
No, I think I'm just confusing it with the grip.
Okay.
So
Yes.
I'd rather.
And it's a good thing to confuse it with because it does very similar stuff. Okay. Orc and grip are very, very similar. Okay. The difference is that grep literally just takes the thing and it just searches for a regular expression. It does nothing with it. Org searches for a pattern and then it can manipulate that pattern. Okay.
Is that chapter
Let
10?
me just
No.
have a look. Yeah, I think it's chapter 10. Let me just have a look which chapter it is. It's part of Find, piping IO, piping 10, chapter 10, analyzing manipulating files. Yeah, it's part of chapter 10, I think. Yeah, it's part of chapter 10. They don't handle a lot of orc. Okay. So I'm just going to try and explain quickly. If I switch, okay, you can see the switch. Okay, the difference between orc and grip. And because this is similar, in my case, what happens is I very rarely use orc, although it's much more powerful than what grep is. But because they do effectively the same job. And I'm just looking for my button. Come on, icon. There's the icon. No. Yes, I got you. There we go. Okay. So we all know what grep does. We spend many hours moaning about grep. Okay. So if we go grep 1, file 1, what's going to happen is it's going to look for that within the file and it's going to show it to me. So if I do file 1, here we go. So let's just do this. Let's do shuff. Just get some random stuff in there. Let's make it 999. Okay. And we output that to file 1. So if I go grep file 1, okay, and we say looking for 1. Okay. Now it brings up all the files, everything. Okay. Now if I do orc, let's see if it does the same thing, and we need to put the file name in there. Does the same thing. Okay. Where the difference comes in is if I do say grep, so for example, I've got my password file here, and I'll say grep, for example, Jacobus in my password file. Okay, it comes back to the 2 entries. You see the whole entry is there. An orc can do the same thing. So orc, looking for Jacobus. Okay, and we're looking at etc password. Okay, but I can do something like this, for example. Let's see. Chat, come here, chat. Okay. So I can do this. Hey, you're supposed to work. Don't give me bullshit now. Why is it not working? Come on, people. You guys are all smarter than me. Tell me why. It's not working. Oh, there we go. Okay. Did you see what was wrong? Did you recognize the problem? The fundamental.
Was it an? Oh, okay.
So why, when I did this, okay, you see this? Okay, now it works. If I do this, you see that it does that. And if I just change this from there to single quotes, now it does what it's supposed to do. You guys know why?
Wow, why? What happened?
Oh, change it.
Yeah, why if I use double quotes it doesn't work? Why if I use single quotes it works? Chapter 16, by the way. The answer is in chapter 16. No, nobody wants to take a guess.
Oh, okay.
Actually,
Does it have to? Oh, okay.
does it have to do with?
Does it have to do with a string or?
It has to do with the quotation. It has to do with the double quotation versus the single quotation. And it's part of scripting. It's something you need to know.
Was it? I don't know, but last time, for me, you know that dollar sign, like if there's a special character, it uses a double quotation mark and then with
Yeah.
something around those lines. But then another, if you don't have special characters, then you use a single. Oh,
That's correct. That's a principle. Exactly the principle. So what happens is, if I use double characters, it's going to expand. It's going to take that $1 and it's going to convert it into whatever the variable is. If I use a single quote, it's going to pass this directly to the application. So it's not going to escape the $1. So if, say, for example, $1, if I have a bash script, let's just create a bash script. Bashy, Banshee. Okay. Banshee is me. And then I can have something like show me $1. Hey. Wow. Okay. If I go and say, okay, fine, make that an application, Banshee, go Banshee, Jacobus. You see it takes my Jacobus in there and it replaces the $1 within the brackets with whatever I passed. If I make that a single quote, it's called the hard quote or hard escape. See, it doesn't convert it. Okay, that's the difference. So double quotes, whatever's inside, the variables that I've assigned gets expanded, is what they call it. Okay, so if I do this, and nope, don't. Okay, and I say $name here, and I run this again. You see, the single quotes does not bring it out. The double quotes, that's the difference. The hard escape versus a single escape. Now, when I use this, awk, with the double quotes, it interpreted that $1 as a parameter. When I use the single escape, it passes it on to awk, and then it shows you. And all that I did with awk is, remember we talked about okay. So all I did with awk is I said awk, okay, F just stands for file delimiter, or the delimiter of the field delimiter. So I told it to use colon as a field delimiter. Then I told it between the forward and the forward slash, that is the regular expression that we're looking for. Remember regular expressions. Okay. And so up until this point, up until that point, it's exactly the same as grep. And then when you go from on there, the print 4, that then goes and it manipulates that and brings back the 1, 2, 3, 4th field. So it does both manipulation as well as searching. Okay, and I just want to copy this, copy link, and I'm going to put it on the I think there is a share link here somewhere. See if I can say. Okay, there we go. Okay, there is a more advanced. This is the type of questions that they asked in the actual exam or in the actual quiz. Okay, as you can see, they are not simple. Okay, but these are more complicated questions. Okay. You can work through them on your own. I suggest you take these 20 questions and you do them sort of like a project, because you'll see this one does a lot of concepts. So you've got the ls there, you've got the pipe symbol, which we discussed today, you've got the grep, which we discussed earlier, you've got the regular expression there. Okay. You see, this is the type of questions they ask in the quiz, where it's like you have to literally know 3 or 4 things at the same time. And next one, the command log file modifies last 7 days source by. Okay, so they go find which one of these will give you the answer. Okay. And they require you to understand multiple concepts. You have to understand the find command. You have to understand the pipe command. You have to understand the sort command. You have to, this is the pipe command with the du command, with the pipe command, with the sort command. You have to understand all of them to be able to answer these questions. This is the type of questions they asked in this quiz. Okay, the first question, the first set that I asked you guys was simple questions. The idea was you should have gotten between 60 and 80% for those. If you got fewer than 60% of the questions right on the first quiz, you have to spend the next 2 days, or how many days until we have right Linux, studying all the time. Okay. If you got 80% for that quiz, you can take breaks to eat. Okay, and you can sleep if you don't. Okay, so think in terms of what you got for the first one. This one is more akin to the type of questions that they asked in the quiz. So I expect these are the type of questions that you will get in the exam. Okay. But this is important, and I'm going to give you a bit of study advice here. If you start with this, okay, and you do the first 3 questions and you can't do them, okay, stop. Go back to simpler questions. Go and do a couple of simple questions, and then only when you feel ready, you come back to this. What tends to happen is when we study and we do questions that's too hard for you, then what tends to happen is your brain goes, oh, and you don't take in information, you don't work. So you have to go back and make sure that you do simpler questions if you're struggling with the more difficult questions, because that's the only way. Then you do the simpler questions until you get them right, until you get a good percentage, and then you go to this. The rule is the questions that you do, when you do like 10 questions, you should get between 60 and 80%. Okay. If you get above 80%, your questions are too simple. You need to make your questions simpler. If you can get below 60%, then your questions is too hard. You need to go for simpler questions. So make sure that the questions that you ask between 60 and 80%. What's going to happen is, as you become more familiar with the work, you're going to find that you move up, and then you get above 80%, then you go and look for more difficult questions. And then you keep your study level between 60 and 80%. That's where you want to be. Okay, if you're below 60%, then you need to find simpler questions. If you're above 80%, you need to find more difficult questions. Your brain likes solving problems, but if the problem is too difficult, in other words, you get below 60%, it gives up. And if it's too easy, it gets bored. So you have to stick with that between 60 and 80% margin if you're studying. Okay, so use this for this. Okay, use the techniques that they told you. Do not study for more than 30 minutes. 30 minutes, 5 minutes break, 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 then take a 15-minute break. Okay. Then once you've done 4 hours, take a long break. Once you've done 8 hours, go sleep. Okay, do not take a 15-minute break, go sleep. Do something else, but take those breaks. It's important to take those breaks, guys, because every time, another trick which is important, and I do this a lot, is that you learn the best just after you've woken up. So what you want to do is you want to sleep, and just after you've woken up, then you go study. When you're nice and fresh, then you're going to take in the most information. Okay, even if you have to do what I do, is I freaking sleep multiple times. So I would go sleep. When I wake up, I'll come and I'll study for 4 hours. And then if I'm still feeling good, I'll study a couple of hours more. But if the moment I stop understanding the work, the moment I stop reading the work, and you get to a point you just read it and you don't take anything in, then I stop. Then it's done. And then in my
sorry, I need a question. Are you going to give us those documents? And thank you so much for talking about the sleep thing, because I've been avoiding sleep so much, thinking that I'm going to lose out on time, but I lose out on time just spending effort on not understanding what's happening. You know what I mean?
It's not going into your brain. You're looking at it, but it's not going into your brain because you're not fresh. You have to be fresh, otherwise you don't take the information in. It's a very there's an interesting study about that. And also, when you sleep at least an hour and a half. Okay, what you can, for example, do the 15-minute breaks. If you go and just lie down in your bed and just rest, okay, that actually refreshes you. So you can do that. But if you take a proper break, an hour and a half. But here's the thing, and a lot of people don't realize it. If I study, okay, and sleep in between, versus a person that studies through the night, I will do better than him the next day. Okay. Part of what your sleep does, and I don't think they tell you this, and you need to understand this. Sleep does a couple of things, but the big thing is the REM sleep, and you've all heard, REM is important. REM does one important thing when you study, and that is it consolidates memory. So what it does is it takes everything you've done in the day, and it goes and it builds a memory with it, and it puts in your brain, and you remember. So when you don't sleep, it doesn't become part of your long-term memory. That's why you need to sleep. So you need to sleep in between your sessions, because when you don't sleep in between your sessions, you can't use the previous day's memory of the previous session's memory in your new stuff. You'll see that once you've slept, you're going to remember it much easier. There's other tricks as well, but we don't have time for those tricks because there isn't time. But sleeping, make sure you take your breaks. Make sure that you're fresh when you study. If you're not fresh when you study, freaking stop. Don't do all kinds of other stuff and then study. Wake up, study, and then you can do other stuff. Okay. But that's important. So this one is difficult questions. Okay, they are hard. I will have to think about these ones. Okay, this is about the level that I need to practice at, because I will get between 60 and 80% for these questions. I won't get 100 for this. The ones we did earlier, I would get 100 for. So this is about the level I need to study at. But you need to understand where your level is and try and find questions that's simpler, and practice those. Okay, let's go to the work that we need to sort of do now. And okay, I do a lot of times what I do these sessions is I want to get you guys ready to work in the industry. So it's not just about studying. It will help you guys get through the exams as well when you understand the concepts and you can actually apply those, because it makes the exam easier to understand. Okay. But I want you guys to be prepared. I don't want you to come to when you eventually get to a job and they talk about these concepts and you've never heard about them. Okay. The stuff that I'm discussing today is in the book, but it's stuff that we had to do in week 7. And I don't know how many of you were actually in week 7. And I know our lecturer, for example, didn't give class in week 7. So a lot of this stuff is sort of self-study anyway. So I'm going to just do a little class on it, give you an idea of what it's all about, how it gets used in the industry, and why it's important. Okay. So let's take it back. If you think in terms of Windows, remember Windows got a C drive and a D drive and an E drive and whatever drives, okay? In Linux, we don't have that. In Linux, we've got one file system, directory structure, and everything gets linked into that directory structure. Believe it or not, Windows has the same thing. The reason why the Windows has got the C, D, and E in whatever drive is purely legacy. In reality, what they do is they actually just take the D drive and link it to a subdirectory within their own thing. They call it something else, but it's a legacy thing and it's still there. But effectively, applications don't care about that anymore. It's just not a thing anymore. So in the Unix world, there's a couple of things that we need to think about. The one is the mounting of a file system. The other one is how do we create a file system, or how do we format a file system? And then what they do in the book is they talk about something called logical volume management, LVM. Okay, and we need to have a quick discussion around that. So let me get a picture up for you guys. In other words, I'm going to draw something with my non-existent artistic skills. Where are we going? We press that button, we go to the whole thingy here. We have to press 1,000 buttons, and then eventually we get to a share, and I can show you, and I can draw pictures. Okay, so when you get a hard drive, or you purchase a hard drive, okay, this is a symbol for a hard drive, by the way. In reality, you know, it doesn't look like that. It's more like that, and yeah, within there's platters, and the new with SSDs, they're just chips, okay? But basically, you've got a hard drive. Okay. When you get that hard drive, it effectively has on the platter, if it's a platter hard drive, or on the little chip. Okay. on the chip, the data on there is either all zeros or it's basically random. Okay, so it can be anything. Okay. On hard drives, it tends to be random. On SSD drives, it tends to be all zeros. Okay. This is a problem. Okay. It's like giving you a blank book. There's nothing in that book. Okay. So I'm giving you a blank book. There's nothing in the book. And now I'm telling you to store information in the book. You know, if you're smart, okay, what you will do is you open the book and in your first couple of pages, you leave open and you'll call it an index. And then what will happen is every time that you write something in the book, you write down what you wrote in the book and you give it a page number. And you write down and you give it a page number. And then on the pages, you'll just number your pages. If you're smart, you'll just buy a book that's pages already numbered. Okay. So this is basically a directory. Okay. It's called a directory. If you don't know why it's called a directory, go to your nearest library. They also call it a directory. And those point to the pages. Okay. Now, in the case of a hard drive, this is actually not a book. It's just a piece of paper. Actually, just do it the way that it is originally. Okay. It's literally a stack of A1 paper. Actually, A0 paper. Okay, you know why it's called A0, hey? Anybody? You know what is the size of an A0 paper?
The size of an AC0 paper?
A0, yes, an A0. So remember we
Oh,
normally
yeah.
work
Oh,
on
yeah.
A4. What is the size of an
Yeah.
A0 paper?
I've never heard of an A0. Are you telling me there's an A0?
Yes.
What?
You use A1, you get A2,
Yeah.
A3, A4, you get an A0 paper.
Yeah,
Okay.
Bubbles, I go to the stationery store like my whole life. What do you mean that there's an A0 and I've never heard of it?
There's an A0 paper.
How big is it?
It's exactly 1 square meter.
Oh, okay.
Really?
A
Everyone
square,
knew this
yes. so,
except for me? That is so
so,
crazy.
so A0 paper is 1 square meter. A1. How big is an A1? It's exactly a half a square meter, quarter square meter, 1/8, 1/16 of a square meter. That's how it works. A0 is a metric unit. And it's designed in such a way so the A0 is exactly 1 square meter, and it's designed in such a way that if you split it up like that the ratio stays the same. If you half it, the ratio, that ratio, and that ratio stays the same. Okay. But anyway, it's 1 square meter. So what happens is, literally, when you get your hard drive, it's literally a stack of A0 paper. So what they do when they print is they do this. They take the paper, they actually print. I'll just give you some interesting. What they do with the paper is they literally do this. They take an A0 paper, and then what they do is they print on this. Okay. Then they do this. They just cut it. Okay. And they take these papers, and then so they print on A0. They literally print how many pages can you put on an A0? They print the front, they print the back, and then they just cut it, and then they staple it together, and they call it a book. But they print on the original, and it's going to be an A0. Okay, because you can print literally, I think, you can put 32 pages on a single A0.
What?
So you print like 10 pieces of A0, and you got a 300-page book.
That is so crazy. Wow. That is so interesting. I didn't know that.
Yeah,
Thanks for
so
sharing.
it gets even, yeah. So what they basically do is they've got a special printer, and what it does is for single pages it's different, but for big books, what they would do is they have a special printer, and what it does is it prints on a piece of metal. Okay, it prints off a piece of metal. Okay, and it prints on that metal, so it just makes scratches on the metal, and they print a red, and they print oh, sorry, this is printing. They print a magenta, they print a yellow, they print a cyan. Okay, and then what they do is they load on the rollers, which is A0 rollers. They just put every color on there, and they do a black one as well. And they set it up, and then what happens is this paper literally runs below these rollers, and as it goes to the rollers, they add the red and the yellow, magenta, and they just add a layer every time. And you get ones that can do 4 colors, you get one that does 8 colors, and they just add the colors like that, and at the other side you get your book, and they adjust it. That's how they print books. And then right at the end, they've done all this. They printed it. Right at the end, they take a cut and they cut it into pages, and you get your little A5 book or your A4 book. You're like, ah! And those things are print fast, eh? They print fast.
Wow.
They print those.
Wow.
Those A0s are coming out more than one a second. So you're thinking. Let's say you're printing something like an A5 book. So you're printing 64 pages. You're printing multiple a second. You're printing over 120 pages a second if you do it like that.
Wow.
So these printers that does like 20 pages a minute, nothing compared to what those nothing. But anyway, that's beside the point. So basically, this is, you get literally a blank slate, and then what you do in computers is exactly what they do there. You take the thing and you mark it off, and you cut it into pieces of paper, and you go and you staple it all together, and now you've got an A4 book that you can use. And the hard drives would do exactly the same. We take a piece of hard drive, which is effectively just a lot of zeros, and we go and we create an index, and we break it into little blocks, okay, and we call those block sectors, and we actually call it blocks and sectors. And now what happens is, if I want something, I look at the index here. In the index, it tells me it's in sector 5, block 4. Okay, and I go look like sector 5, 1, 2, 3, sector 5, and block number 4. That's going to be in that information. So that's what it does. Now, this process is called formatting in the Windows world. Okay. In Linux, we don't call it formatting, but it's the same process. Let me just see what they call it in Linux, because I actually forgot now. They might actually call it the same thing. Yeah, they still call it formatting. Okay. I thought they had a different name for it. Because we use the command that we use to create this called MKFS, make file system. Okay. In chapter, which are we chapter 20, we are working with a couple of commands, and I'm going to share out my normal screen just now. Okay. So when we start off with a hard drive, we want to format that hard drive to get a file system on there, file system on there, and then we want to attach that hard drive into your directory structure. Okay, so I'm going to try and do that quickly just to show you how this works. Let's see if I can find this one here. Okay, sorry, my setup is not what I want it to be, but considering that I don't give glass, it's probably not that big of an issue. Where are you? There it is. Okay, so we got the Linux here. So you can see that. You can see what I'm doing at the top here. Hey. Okay. So what I'm going to do is I'm going to just add another hard drive to this computer. I'm just going to say add hardware. I'm going to create a hard drive storage. I'm going to create, you don't have to have a big one. Okay. And I'm going to create another one just because I can. So I've basically created 2 new hard drives, and I'm just going to attach it to my system. So in the command to check what your block devices are, block device is just hard drives, is another word for hard drives. So you can see in Ubuntu, it uses these loop devices. Those you can ignore for now. It's just the way that it does these snap packages. And we don't do that at all. You can ignore it. What you are interested in is in this stuff here. Okay. Normally, and I think in the book they do discuss it, you have SDA. S actually stands for SCSI. Okay. So it says SCSI disk A, SCSI disk B, SCSI disk C. Again, in the dev directory. Let's go there. SD. Okay. See, there's no SD, so that's the SCSI disks. VD just means it's a virtual disk. Okay, so it's the same concept, the VG disk, and we have to do that. So the first thing we need to do is we can use LSBLK, and that's going to show us all the disks on the system. Okay. So now I don't know how to explain this. Okay. Let's see if I can have a graphical application here. I don't have Impress installed. Okay, well, this thing is busy installing. Okay, I'll explain the concept. So when we get a hard drive, this hard drive is say 4 terabyte or 2 terabyte or 100 gig or what it is, doesn't really matter. Okay, it's literally just blank. Now we want to split it up into blocks and sectors. So that's the first part that we do. Then we say, okay, fine, this hard drive's got blocks and sectors. And then we have something called partitioning. Now this we've discussed in CNA. So this is where your CNA sort of comes in. In CNA, we discussed partitioning. We have partitions. We have the GPT partitions, and we have, yes, that GPT before GPT was GPT. We have GPT partitions, and we have MBR partitions. If you remember your CNA, that's where it comes from. So we can take a hard drive, and we can split it up into different sectors. Let me show you how to do it. So in Linux, the command that we use to do that is called fdisk. So I have done LSBLK, and I have a disk here, VDB, and this disk is not formatted or anything. It's just literally an empty disk. There's nothing on it. So if I go fdisk, fvdb, okay, and I press P for print, it shows me that it's an empty disk. It's a 5 gigabyte disk, There's nothing on it. Now I can break it up into something called partitions. I can say create a new partition, primary partition 1, whatever the case might be. Okay. Now you can see it's created a primary partition. Here's the thing. Part of the reasons why we have partitions is you want to split. Sometimes you want to split like your data from your applications, or if you're running multiple operating systems, say for example, you want the same disk to run both the Windows and a Linux, you'll have 2 different partitions. Sometimes it's a single partition, sometimes you split it. In the professional world, in the server world, we definitely split our data and our applications. We don't want those on the same drive, because what's nice about that is if we need to reinstall or we need to upgrade, we literally just replace the operating system and your data, it doesn't stay the same. If we don't do that, the moment you format your disk for your operating system, you lose your data. Now, Linux, when you installed it, okay, it would have created 2 partitions anyway for you. So see, it does this automatically in the background. You don't even notice that it's there. But it's done it in the background. In our case, we have now created our own one. Okay. Let's just do the VDB one. So I've created the VDB one. Okay, so that's the first command you need to know. These are just commands to create it and W for writing it out. And if I go there again, it should be there. Okay, so I've created like a 5 gig partition. So that's the first command. The second command is we need to format it. Okay. Now, unlike Windows, where you just literally format it, in Linux, you can format it in different formats. ext4 is a standard one. There's other ones as well, which is really advanced ones that we use on servers. For now, just remember ext4. I can't remember if they just mention the others. They don't specifically tell you more about it. So there are other ones. They do mention it in the book. Know that there are other ones. Know what their names are. But other than that, you don't need to know the details. Okay. Now go device VDA, and you can see it. Let me show you here. Sorry, I'm jumping around a bit. Can you see the file name? VDB means hard drive. VDB1 means hard drive partition 1. Okay, so what I'm going to do is I'm going to say create a file system on VDB1, which is basically a virtual disk, drive B, and partition 1. Okay. Okay, what did I do wrong? Who can tell me what I did wrong? Put your hand up. Yes, this is all part of chapter 20. And they actually did ask this question, by the way, in the exams, in the quiz. Okay, that is make file system. That is check file system. This file system check versus make file system. Okay, so that says make file system. That just checks the file system. So I made a file system. Okay. Now, so that's the first command you need to know is how do you make a file system? You format the file system called in make file system. Guys, thumbs up if you understand up until now. If there's any specific concept you're struggling with, you can either just unmute yourself and ask, or you can just post quickly on the thingy. If you are still with us, just give me a thumbs up and I can continue. Okay, so obviously you've heard about these concepts before. So what I can then do is I can say take that hard drive and attach it to my directory. So we've got all the directory. So I can say, for example, this is disk 1. So I'm creating a directory and I say mount drive VDB1 to disk 1. And what I've now done is I've effectively attached that hard drive to this directory. Okay, let me prove it to you. So let's do what we've done before. We say, let's touch something there. Let's catch file 2 there. And you can put in some data there. Let's do a shuff I1 to 20 and file 3. Okay, can you see there's now 3 files in this directory? Okay, now what I'm doing is I'm going to say unmount disk 1. There's no files there anymore. Because disk 1 is on hard drive VDB1. If I now go and mount it, okay, very simple mount device thing. If I go to disk 1, oh, the files are back again. Okay, so let's do this whole process again. So we do fdisk for device number 2, VDBC. We say we want a new partition. We're happy with the whole thing as a partition. We write it out. Let's make a file system on it. VDC1. And let's go mount device VDC1, disk 2. No. Mount device VDC1. Let's mount it to somewhere disk 1. And now we've mounted the other drive. This is drive 2, and it's got file 5, file 6. Okay, so if I go to disk 1, guys, I work slightly faster. Otherwise, I got so bored when they work slowly. So I work slightly faster just to get the concepts through. If I'm working too fast, you tell me, and then I'll go slower. Okay, so I've mounted the second hard drive to the disk. You can see there's a directory there now. Now what I'm doing is unmounting that disk. I'm mounting my first drive. VDB. So I'm driving my second one there. Come on, what's happening? What's happening there? Okay, hold on. Dev VDB1, disk 1. If I go to disk 1, theoretically there should be different files in there now. Can you see there's different files in there now? So I've mounted to the same directory different hard drives, and then depending on which hard drive I mount, it's going to have different information. So I can do things like this now. Okay, so that's the basic concept of mounting partitions, hard drives. Okay, and making the file system MKFS, as well as checking the file system. Okay, that's the easy stuff. Okay, let me just go to the right stuff here. Get the right stuff. You've done the hard drives. We have the LS block device. Okay, so if we do LSBLK again, you should see all the new drives. You see that this is the original drive. It's a disk, partition, partition. This one has got a new disk with a new partition, a new disk with a new partition. Okay. fdisk, just loading the commands. It is in chapter 20. File systems, just learn the different types of file systems. You don't have to have the details. The one that we use is ext4. ISO 9660, for example, is for CD-ROMs, DVDs. So they're sort of gone out of fashion. VFAT is the Windows, old Windows stuff, still used on, what do you call it? Still used on USB sticks. Okay. Wipe fs command. So what happens is, so now I've used this disk and I'll finish with it. Okay. Okay. So now I've got this disk, VDB here. It's got a partition. Now, what sometimes happens is I need to reset that disk so I can use it for something else. We can use something called wipe FS. And if I go there, you'll see that the configuration is now gone. Okay, so that's what wipe FS does. Make file systems already done. Mount we've already done. Unmounting. So obviously you've got mount, and you've got unmount. This one just mounts a disk, this one unmounts it. Okay. Thumbs up if you know about FS tab, thumbs down if you don't. Stop. Okay. So obviously, when the computer starts up, we can now mount directories. So, but we need to know which directories to mount automatically. Okay. And then all the FS tab does is it literally tells you what all the directories is. So if I open that up, it's going to tell me that I've got this disk. Okay. And it's mounted on my root directory, ext4. So say, for example, the one that I just did, I can say, well, okay, I want the device VDC1. I want it mounted on MNT disk 2. It's a ext4 file system. I have default 00. Okay. Tells you the disk. It tells you which directory to mount it on. ext4 is the file system type. This is just the options. You could have multiple ones, things like read only, etc. And now what happens is I don't have to, I just go mount disk 2, the system control, daemon reload. There you go. Okay. So what will happen is this directory is now automatically mounted when I boot my computer. So I have to don't do it manually. So most of the times that's what we do is we just put it in there, and then for the time of that computer, it's just the directory. We can also move disks from one computer to another one. We plug it in, we just mount it, and we put it in the FS tab, and from now on, that computer is on the new machine. Okay. Okay, you can look at that. It is still in the chapter. Or part of the chapter. Okay. Now for logical volume management. Now most servers that you will go into will actually not use the method that we just spent half an hour discussing. They won't. Okay. So here's what happens. When I've got a server, so now the difference between a server and a PC or desktop is a desktop is used by one person. So if something goes wrong on a desktop, you go, okay, you know what? Give me your PC for half an hour, give me your PC for a day, I will fix it up. If you have a server and it's a small company, there's maybe 20 people that's using the server. So it's considerably more difficult to say, well, give me half an hour, I'll fix it up, and 20 people can't work, or give me 2 days and then 20 people can't work. In a big organization, you'll have 5,000 people. If you Google, you'll have 2 million people on a server. Okay. So you literally cannot switch this damn thing off. Okay. Which is a problem, because what happens now is, what happens if, for example, I run out of disk space? Now I have to increase my disk space. Okay. That type of thing. How do I back up this thing? How do I make sure that it always runs? And one of the ways that Linux handles is something called logical volume management. Okay, what it basically comes down to is it's a virtual disk. Okay, so let's draw the picture. Let's draw a picture. Press the button. Go share. Share. Where is it? 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 Hang on. There we go. Okay. So remember we had a hard drive. On that hard drive, we split it up into several partitions. And then on that partition, we can put a file system. Okay. Now what we can do is we can create our own virtual fake system. Okay. So what we can do is we can say, I've got a volume group. Okay. And then my volume group consists of a logical volume and a logical volume. Logical volume. That logical volume looks like a hard drive. In actual fact, or it looks like a partition or hard drive, depends on how you set it up, but generally this looks like a hard drive. Okay. Volume group. Here's where the magic happens. Those are physical volumes. So what I can do is I can take a couple of physical volumes. I can attach it to a volume group. Now I can take that volume group and I can split it up the way that I want it. Okay. What's cool about it is I can do this. If, say, for example, my hard drives get full, okay, I can literally just attach another physical volume, attach it to the volume group, and now the logical volume or nothing at the top changes. This applications and everything still uses the logical volume, but I've actually increased my disk space at the bottom. What also happens, which is actually more common, is that my hard drives fail. A hard drive only lasts 5 years. After 5 years, one of my hard drives fails, so I want to remove that hard drive, and I can do exactly that. I can take this hard drive, I can remove it, okay, and my logical volume at the top still looks the same. Okay, so this is what logical volume management does. Okay, you can do other things as well. So, for example, you can do something called snapshots. So I can tell it, listen, exactly at 1 o'clock on Saturday, create a snapshot. And then what happens is, if ever I want to refer to that snapshot, I can tell the system, listen, tell me exactly how the hard drive looks on that snapshot, and it goes back to that. You can't use it. It is like a backup, okay? But we don't generally call it a backup because it's not good practice to use it as a backup, okay? But you can literally just roll back. What we do with that is Windows are, compared to Linux, Windows is really unstable. Linux and most Linux systems, you reboot them when there's a software update. You don't reboot them because they stop working. It is very, very uncommon. So most of my servers, around six years, I've had machines that I've shut down that ran 5 years. Okay, and the reason we shut it down is because the hard drives became old and we had to replace the hard drives, not the machine stopped working. Okay, so for Linux machines never break, but Windows machines are not quite as unstable. So what we do a lot of times is we'll literally take a VM a Linux that runs a virtual host. Okay. We run Windows on there. We run a Windows within a VM. Okay. And then we do snapshots normally every 30 minutes or so. We do a snapshot. Then what will happen is when this Windows machine breaks, we say, okay, when is the last time that it worked properly? And we just roll back to that time and date and we boot it up and it works, rather than spending half a day trying to fix it. Okay. And that's one of the reasons why we would have, for example, because you do a snapshot is done on a hard drive. So what we'll literally do is we'll do this. We'll go, we have the operating system on the one hard drive. We'll have the data on the other hard drive. If something goes wrong, all we do is we take this drive, we roll it back 30 minutes. Okay. All your software is still there, and your data is on a separate drive, so you're not losing any piece of data. It's just working. Okay, so that's the type of thing that you do in big environments where there's a lot of people using the system. Okay, but let's get back to volume management. Okay, so I'm going to just show you quickly how it all fits together, and then we can go to sleep. Guys, you are not interacting. Okay, again, thumbs up, thumbs down, thumbs up if you understand, thumbs down if this doesn't make sense to you. Okay, let me quickly show you how to set this up. So we've already set up 2 hard drives. Okay, so what I'm going to do is I'm going to just take those hard drives. Okay, and I'm going to wipe them. Okay. And just an A there. Okay, so if I go now and I go to VDB, you'll see there's nothing there. VDC, there's nothing there. Oh, delete that. Okay, then now there's nothing there. Sorry, I
Okay,
should.
but can we just summarize everything before we go? Just to hear it in a different way.
I'm gonna just do a demo for you guys quickly.
Okay.
Where is it? Yeah, these people, okay, that study and work so hard and shit, and they want things summarized and stuff. You know, what's wrong with you? You make the rest of us look bad.
What do you mean? I'm just trying to hear it in a different way so that it kind of sticks in my
I
memory.
understand completely,
You
and
know, I get
you're,
it, but I just need to hear it differently.
you're absolutely right. I'm just joking with you. It's a good thing, not a bad thing. Okay.
All right.
So let me just do this. So there is a problem here. You see, it didn't want to delete that disk. Okay. The reason why is because the disk is busy, and if you look at the F tab, it's because we have it in here, and because it's in there, it's mounted, and you first have to unmount it. So I have to unmount it first, and only once I've unmounted it can I actually go and delete it. Okay, that's the reason why we couldn't delete it. Okay, so what we're going to do is remember we had the thing where we had physicals, we had physical drives, and then on top of the physical drives we had groups, volume groups, and on top of the volume groups we had logical volumes. Okay, so what we're going to do is the first thing we should do is we're going to create a new. It's not installed. I think it's LVM utils. I think. You have a look. Yeah. LVM utils or LVM tools is normally the right one. LVM2. Okay. LVM2. Okay, there you go. let's say impress. There we go. Guys, can you see properly everything? Okay, so just close this up. There's a blank disk. Delete that. Get rid of that. Oh, where are we? We might as well. We'll block there. We've got a little block there. That block goes on top of that one. We can have another block on top of that one. And we can call this. And we can call that physical disk. Physical. And we can call that volume group. On top of that, we then have a logical volume. Okay, we said we had the physical disks. We can have multiple physical disks that all contribute to the same volume group. Okay, so the first thing we want to do is we just want to create a volume group. Volume group create. The name should be ITLSA. Yeah, that's fine. Okay, hold on. Okay, and it wants a physical drive to start with, and we will start with VDB. Okay, so I've created the physical drive. So VGS, which is list, I have now created one volume group called ITLSA. Okay, it's got one physical drive, and it's 5 gigs big. Okay, so it's very small, but we'll ignore that for now. Okay, now I say LV create a new drive called, say, for example, exam papers. Okay, it has to be on LTSA, and it has to be, how big can we make it? So we'll make it 3 gigs big, and it has to be 3 gigs. Okay, so now I've created a new logical volume called exam papers on top of volume group ITLSA. These attributes sort of ignore, but you can go look into exactly what they are, because you can do funny things with it, and it's 3 gig size. So now what I can do is use it exactly the same way that you would use a file system. So ext4 device exam paper, ITLSA / exam papers. Can you see? So that's my volume group. That is my logical volume, and we called it, okay, and I can use it as if it's a hard drive. Okay, I can mount it. ITLSA, I need to spell that correctly, and I can mount it on disk. I'll go to disk. There it is, and I can make a file 1, and I can random, and I can put something in there, and we can put the random file in there, and block size 4 megs, count, say, for example, 2. So I've now created a 40 meg file there that's got random data in it. Okay, so that's this one. Okay. Now what happens is my hard drive gets old. So what I can do is I can say, okay, you know what? VG, I haven't done this for a while, so you'll have to just excuse me. I'll have to just look up everything quickly. VG extend, I think. LTSA, device, VD. I'm just guessing. Nope. Is equal to volume group. I just want to get the parameters. I did have it right. VG extend. Oh, it is successfully created. LT. Guys, you are tired. ITLSA, that's why it didn't work.
No, we're just watching you work this thing out. That's what we're doing.
ITLSA, there we go. So now what I've done is I've attached to ITLSA, I've attached VDC. So if I do VGS, which is list, now I'm seeing there's 2 physical drives there with 1 logical volume. Okay. If I go to my my disk here, my disk 2 here. Okay. Disk 1. Okay. Everything's still there and it's still working. And I've now added a new disk. Okay. I remove disk. Okay, so now we say, okay, fine, let's move the data off disk. Is the VDB. So what I'm telling it is I'm going to remove disk B. So remove all the data off.
Okay.
Okay. Now what you'll see while this is busy is the files are still here. I'm still working on my virtual disks. Everything's still working. Okay. And then I say, okay, fine. Actual fact, this is this. So you can actually see while it's doing its thing. So all the files are still there, and we are verified that they're still working. I'll say VG reduce, ITLSA, VDB. Okay, and I go fdisk device VDB. And now what I've effectively moved, I've moved everything to the C drive. Everything is still there. And what I can do is I can literally go back to my thing imaging here. You guys, did you guys see what I was just doing or not? Did I not share it?
Well, we were following, honestly.
Okay,
And
so
we're trying to make sense as you go. But you keep on, I don't know, doubting if we get you or not. We do get you. We're just following you. I don't know about others. Others can advocate for themselves.
okay, so there we go. So okay, so you did see this. Okay, so what I'm going to do is I'm going to now literally go to the top here, and I'm going to remove that hard drive, this hard drive here. I'll take that and tell it to.
Okay.
It might not allow me to do it live. A lot of times it doesn't.
Oh.
So I've removed that disk. and the data is still here and working. So I've literally to replace the drive. I took my one drive, I took it away, I put a new drive in, and I've moved the data from the old drive to the new drive, while my applications, which can access these files, and this could be a database, it could be anything, is still running. That's the type of thing that you can do with logical volume management. But the basic principle is you've got your physical drives, you've got a volume group on top of that, and on top of that, you've got a logical volume, and you can mount the logical volumes. And the only difference is this names here is different. So if you do, so you can give it your own name. So you'll see that for a drive, it'll always be vdev, sd, whatever. With this, you can actually give it your own names. So again, we can add this to the file system. We can replace that. We can say this is ITLSA exam papers. Okay, there we go. And okay. Sorry, device. Okay, so I've mounted it, and on disk one, it's there again. So that's basically logical volume management, and we've done chapter 20.